When inhaled, cigarette smoke travels through the airways to the lungs. From here, nicotine passes directly through the alveolar epithelium into the bloodstream. Although nicotine can interact with a variety of receptors in numerous tissues, as we will see, it is its interaction with specific receptors in the brain that creates the dependence associated with smoking. Within seconds, nicotine is delivered to millions of neurons in the central nervous system. Here, within the midbrain, nicotine interacts with the alpha-4 beta-2 nicotinic acetylcholine receptors. Acetylcholine is the natural ligand for these receptors. However, nicotine, also an acetylcholine receptor agonist, has a higher affinity for the alpha-4 beta-2 receptors. Located on postsynaptic neurons, these receptors are comprised of 2 alpha-4 and 3 beta-2 subunits that form a channel for transporting ions through the membrane. When 2 molecules of nicotine or another ligand engage binding sites within the receptor, the ion channel is activated. Looking into the receptor, we see that it is closed, but activation by ligand triggers internal rods to open the channel for the passage of calcium, sodium, and potassium ions. This initiates electrical impulses, generating an action potential. This signal is rapidly transmitted down the axon to the reward area of the brain. Here, the impulses stimulate the release of neurotransmitters, including dopamine. Dopamine triggers additional signaling events that stimulate the reward circuit, generating short-lived feelings of well-being, improved mood, and increased attention. Every time tobacco is used, dopamine levels surge. However, nicotine is eliminated rather rapidly, causing dopamine levels to decline. The result, a craving for more nicotine. With continued tobacco use, alpha-4 beta-2 nicotinic receptors undergo complex adaptive changes, including upregulation and desensitization. Over time, these and other downstream changes contribute to a stronger need for nicotinic stimulation to achieve the rewards of smoking.